So next we're gonna have Katya, and he's gonna bring all these topics down to earth. Industry, hardcore industry, right? AI in industry. Thank you.
I have no sound? Okay. Good morning, everyone. Thank you for being here. I'm Katya Santos. I'm a manager at Closer working with data science projects. And today I would like to talk to you about the applications of AI in industry, and actually in Industry 4.0. I'm going to be speaking to you as the audience, but you, namely the people in the industry that are in the audience. But those of you that are not specifically from industry, I would like to challenge you to listen to what I have to say and try to apply it to your own sectors and your own markets, because I'm sure you'll find many points of contact. So I tried to structure the presentation around three major questions. How did we get here? What Industry 4.0 actually means? What were the triggers for previous iterations of industrial revolution? And what happened that triggered this fourth iteration of industry revolution? Second point is actually the main core of this topic, which is how can AI impact the industry? And then lastly, I'm going to start, but I'll try to explain how can we start going the road of digital transformation. When I was preparing this presentation, a friend of mine told me that when you're doing these kinds of discussions, you can have three goals: teach, motivate, or inspire. So I decided that my goal today is to inspire you with the possibilities and then motivate you to get you on the road if you're not there yet and keep going on that road because the benefits are there. So, how did we get here? What is actually Industry 4.0 and how did we get here? Industry 4.0 means that this is the fourth iteration of something, right? So in the beginning, here. I have no thing. I can't see it. Well, in the end of the 18th century was the beginning of the Industrial Revolution, when the steam engine was first utilized in the textile industry to start going from a more handcrafted manufacturing process to a real industrial process. Then about almost 100 years later, the assembly line appeared and electrical power appeared, and therefore we saw a shift in the industrial process, and that was the rise of Industry 2.0, if we want. Then, about 100 years later, not the appearance of electronics, but the decrease in their cost made them possible to be used in a widespread utilization in industry. And so we had electronics, IT systems, and robotics being integrated in industry. That was the third iteration of the Industrial Revolution. Which leads us to today. Today we're seeing the rise of smart factories, autonomous systems with large integration of information moving around through the processes, big data, IoT, interoperability, machines and entities in the supply chain that can make autonomous decisions. What was the triggers? Well, we saw that for the first one was the steam engine, then we had electricity and computing power, but for the fourth one, we have a host of things that are happening and being integrated together to make this work as a new age of automation. Okay, so how can AI actually impact industry? The industrial cycle has not changed that much since the first industrial revolution, right? We had raw materials go to manufacturing process, then we had distribution to a retailer or end customer. So this cycle didn't change that much in terms of the entities that are there. I'm not entirely sure how R&D was involved in the end of the 18th century, but now it's definitely a player. So let me tell you about what we can do, some examples of what we can do in each of these points. So for example, in the raw material side, you can use artificial intelligence to forecast the availability of materials. You can forecast the prices of the materials. You can apply optimization to find what's the best route and what's the best method to get the right materials that you need. And when I say method, it can be, is it going to be by truck, by road, a railroad, shipping, airplane? You can have the multiple variables of availability, price, of the material and of the transport and create an optimization process to get the best solution for your business. In the manufacturing side, I already spoke a bit about smart factories, and I'm going to go deeper into this topic in a few minutes, so I'm not going to explain too much about that right now. But you have optimization of production plans. Imagine that you have, I'm going to simplify, you have 10 products, and you have 6 production lines. You have a list of orders, and you have to produce different things. So you have the costs of producing each product in each machine, setup times, the different availability of the different machines. So even with only 10 products, the number of variables and combinations becomes very hard, very fast for a human mind to actually optimize this plan. But if you give it to an algorithm, it's something that they're excellent at doing. It's what they're meant to do. So you can have an optimization of production plans using AI. And even if you only increase marginally the gain in each order that you have, if you have hundreds of orders per week or per day, the compound interest builds very fast. I'm not going to go very much into predictive maintenance, because Vasco already spoke quite a bit on that, so that's saved me time. Distribution. As before, we have distribution optimization processes, where you can find the best routes to go to the best places in the best time. And we have the rise of autonomous vehicles. This is something that is not in the future. It's already started to happen. I'm sure most of you have heard about Amazon and Walmart doing distribution of orders using drones. So this is not something of tomorrow. It's happening today. And on the customer side, you can forecast demand on time and on geography, and you can use that to actually impact, I'm going to go there in a minute, to actually impact the whole cycle. The customer is the one influencing the entire cycle. And because of that, you will have an optimization of your warehouse inventory. Does this work? Yeah. Your warehouse will be adapted to the forecast, and that will, in the future, lead to literally no warehouse necessity. And then I want to go to the R&D section. Depending on the size of a company, the R&D section can be either very small or very big. If you have just 2 teams, 3 teams working on developing new products, you end up having teams that know very well what they're doing. They know the information of what they're doing very well, but sometimes the flow of information between different teams is not that easy. And if you're working with different geographies, then it gets completely messy. But you end up with silos of information for different teams. What if you can have a chatbot or a bot that search through all this information, finds connection points that the humans have overlooked? You can find innovation much faster, you can find insights much faster, because you're applying AI to your research. We already heard a little bit this morning about AI-based learning in the pharmaceutical industry, for example, where you have simulations testing new configurations of molecules and their effects on biological systems. That's already happening as well. And the digital twin is something, for example, where you can build a digital twin of your product before you actually go into production and figure out if it's worth investing in the real production beforehand. This is a very complex image that I found, and I think it's very interesting. I'm not going to go into all of it, but I wanted to show you that all of this doesn't happen overnight. So you will have to develop probably iteratively, and you have a maturity point in your processes. I actually just want to talk about one, because if I go to all of them, someone will kill me. I'm just going to talk about the first one, the warehouse management, where you can go from absolutely no complexity, no integration, no interoperability, which is basically a warehouse standalone with no integrations. And you can go to an automatic warehouse where you have robotic systems doing the picking and doing the selection of the products. You can have, further down the scale of maturity, you can have an automatic warehouse network where all of your warehouses scattered throughout the different geographies know what is there in each point. And then you integrate with a supply chain network where not only do the warehouses know what's there, they also know what the demand is and where the products need to be. So you have a network that basically controls the flows of products from side to side. And at the end of the maturity scale, you have no warehouse and supply chain. Why? Because in the future, enterprises should be able to respond quickly to clients' demands. So when a client places an order, the integration along the whole system will be able to trigger production and a delivery in a very short amount of time. So ideally, we should have no need for a warehouse and supply chain. I'll be very happy to talk with anyone about the rest of the image if anyone wants to come meet me during lunch. Factory of the future. This is why I didn't want to talk too much about the smart factories in the previous slide, because here's what I want to go into a little bit more detail. So what we have here, well, we talked a little bit about the supply chain already, and the supply chain is basically a set of entities and processes and information flow. So using blockchain to control the integrity of this process makes perfect sense. We also would have predictive analytics, predictive machines with analytics, which basically means you have a layer of predictive analytics all over your factory. You have IoT sensors. I have no idea where my thing is. IoT sensors for supply chain management. Imagine that you have one sensor per machine in your production line or per moving part in your production line. So you're going to have tons and tons of data being generated. That data needs to be searched, analyzed, and then found triggers to what actually needs to happen. Imagine that you have then an augmented reality system on your factory. You have your technical staff looking at the different, not products, the different equipments, and having visual alerts that that machine in that section is having a problem. There's a spike in pressure, a spike in temperature, whatever. You can find the problems much faster and react to it much faster. And you can have, instead of doing planned maintenance where you have to stop your lines, in a time that you don't really know if there's a problem, you'll actually be able to find the problem much faster, a real problem, and only act on it when you need it. Then we have modular equipment. And in modular equipment, this is something that's going to scare a lot of people, because I know that changing the factory floors, changing the equipment that is there costs a lot of money. It makes people have to stop the machines, change what is there. But modular equipment is what will allow the enterprises to have a greater flexibility in what they could build. So if they have modular equipment, they can rapidly adapt to a new product that needs to be built today or tomorrow in an hour. If you have to stop your machine for 12 hours if you want to change the type of product, that's not going to happen. That's not going to work well in the near future. Then we have our RFID sensors and computer vision that basically allows the enterprise as a whole to know what's being produced, what do I have in inventory, what's being distributed, to know end-to-end where everything is. Cobots. That's not a typo. Those are actually collaborative robots. Usually in the industry, you have big robots that are protected behind shields or cages because they're programmed to work regardless of the humans. So the shields are there to protect the humans in their environment. Cobots are designed to be aware of the humans. They are designed to work with the humans. They are collaborative. So basically, they are designed to do very precision, fine work that the humans are a bit more clumsy to do, but they are programmed to work with us, programmed with the humans. Also, we have wearables. You'll be able to not only track where everyone in your factory is, you can do optimization on that. For example, you can optimize the factory floor based on the patterns of the people that are working around, but you can also use this to improve the quality of life of your workers. You can, for example, know if someone is overworked or having a moment of higher stress or higher tension, and you can give them a warning, look, it's time for you to take a break, go take a coffee, and then come back to work. And lastly, as we already talked about, the autonomous distribution systems. Here is a truck. I don't know if in 10 years it will be drones, a flying car, we don't know, but it will be certainly autonomous. This is only possible because we have convergence of multiple technologies. We already talked about advanced robotics, and for example, the cobots. We have additive manufacturing with, for example, 3D printing, where you can do printing of spare parts or prototypes instead of having to build a full-blown product at the beginning. Augmented reality, simulation, horizontal and vertical integration to make sure that information runs freely throughout the whole points of the enterprise. IoT for the machine sensors. Cloud, because obviously it will not be possible to process the hosts of information that are being generated any other way. Cybersecurity. Cybersecurity is a very important point. After we have all of this running in the cloud and running with full integration, I'm sure no one would want to have the production plan being hijacked by someone else and being literally holding hostage the entire production. So cybersecurity will play a very big role. And of course, at the end, but not the least important for sure, big data and analytics, where you can have the layers that will analyze and make sure that everything is giving the right insights and the right information to the humans that will need to operate everything. So, benefits. I've told you the what, I've told you the how, more or less. Now I'm going to tell you why. Real-time data in a real-time supply chain in a real-time economy. Real-time is going to be the key word for the next few years. And the industry today is not yet operating in real time. So this is going to be the next step. Enhanced productivity and enhanced business continuity to automation, optimization, and advanced maintenance. Better quality. You're going to be having monitoring throughout the entire processes. So you're going to have a better quality check and a faster quality check. Better working conditions for the people that are working there. Personalization and customization for the new customer. And I have new under quotes because we don't know what the new customer is going to be. This new processes is going to probably most likely generate new revenue models, new business models that will attract different customers than the ones we have today. So this is going to be the need for flexibility, personalization, and adaptation is going to be greater than ever. So, now that I've scared you with the possibilities, how do I begin? How do I go from here? If I haven't done anything yet, or if I've started but I'm not further down the maturity scale than I would like, how do I begin? First thing to do, in our opinion, is to ask the right questions about your business. What processes do I have? What data am I generating? What data do I have and I'm not using? Where do I have the most inefficiencies? What data should I be getting that I'm not getting? After you ask all these questions, you'll find yourself with a list of things where you'd want to work on, and you will start prioritizing them based on value, based on what's going to bring the most value to your company. But value alone is not the most important. You need to find something that is valuable and doable in a short amount of time. Because if you find something that's really, really valuable, but it will take 3 years to implement, you shouldn't start there. You should start with something that is more achievable. So, just as a note, we have found a survey that says where companies are planning to invest the most in the next few years. And unsurprisingly, optimization and predictive maintenance are right at the top. So, you ask the right questions, you have your roadmap, you have your prioritization. You need to have the right skills on your team, because the technical side will be very important. So start incorporating the right skills in your team, either by building your own teams or finding the right partners to work with. And, as I was saying before, develop small modules. Don't try to go for the big elephant at the same time. Start with a small leg that has value. I'm going to share with you an example of a module that we developed for a Portuguese industrial client. And I want you to understand that even small modules can have a lot of value. So the problem here was the allocation of interchangeable orders. What does this mean is that you have a list of orders that can be produced in different plants. And there's a different profit for making them in the different plants. It's not the same doing it in factory A, B, or C, but you then also have to account for logistics costs, because some orders have to be aggregated to be delivered together. So if you have a list of hundreds of orders, you have various possibilities for the plants, you have the logistics costs. For a human, this is very hard to process, very hard to get an optimized idea. But we built an optimizer using a genetic algorithm, and that algorithm gets the list of orders and then outputs the production plan for each of the factories, and all they have to do is follow those plans and make sure that the logistics are happening as they should. And here, even if you have, I don't remember exactly the number that was the profit from this, but I know that on each week you were having a better production plan than you were having before. So even if the margin was small, and I don't remember the name, I know it was not small, I don't want to deceive you, so I'm not going to go with a number because I'm not sure. But this is something that very fast. It's a small module, it's not interconnected, it's not going from raw materials to delivery, but this is a small module that has value, and it's a stepping stone into the next path. So my challenge to you, if you're not started yet, start with small steps, but start. That's the most important message. Just keep going onto the road of digital transformation and using AI in your systems. Thank you.